Go over the 2017 AP Calculus free response questions. Number 1, a tank has a height of 10 feet. The area of the horizontal cross-section of the tank at height h feet is given by the function a, where a of h is measured in square feet. The function a is continuous and decreases as h increases. Selected values for a of h are given in the table above. Part A says use a left Riemann sum with 3 subintervals indicated by the data in the table to approximate the volume of the tank. Indicate units of measure. So we could sketch out these points if you wanted to, if you're very visual and you want to see that. I'm not going to sketch them out, but I will tell you that your A sub h, or A of h, is square feet, and this is in feet. So if I ever talk about an area, which that's what I'm trying to find here, it's kind of like the area of rectangles, and that's going to be feet by square feet. So my units should definitely be cubic feet. So even if you didn't know how to do this problem, if you at least wrote cubic feet, sometimes you'll get a point just for doing that. All right, so on part A, we're using a left-hand Riemann sum, so I want to know the width of the first rectangle. The width is 2, and the height is going to be the one on the left. So sometimes I'll do little triangles, if you remember from class. So I'm going to have 2 times 50.3. The next one has a width of 3 and a height of 14.4. The next one has a width of 5 and a height of 6.5. Okay, and if you find that value, you end up getting 176.3 cubic feet. And you can find that on your calculator. This is a calculator question. So B, does the approximation in part A, is it an overestimate or underestimate of the volume of the tank? Explain your reasoning. So a lot of times if you think about whether the function is increasing or decreasing, you can come up with whether or not it's an overestimate or an underestimate. So if you think about something being continuous and decreasing, so it could look like that, or it could look like that. So it can be concave up or concave down. So if we're doing a left-hand Riemann sum, we end up going over the actual area. The actual area would be the area under the curve. Okay, so that would be an overestimate. So let's see, even if our concavity is concave down, is that still an overestimate? Yeah, it would be an overestimate for that as well. So really, if you're talking about an underestimate or overestimate for an area, you want to talk about whether it's increasing or decreasing. So you can say something there. So we can say something like, since A is decreasing, a left Riemann sum is an overestimate. All right, part C. The area in square feet of the horizontal cross-section at height h feet is modeled by the function f, given by f of h is equal to 50.3 over e to the 0.2h plus h. Okay, so basically, previously we had the area of the horizontal cross-section came from this table. Okay, so now we have this function that's kind of approximating this table. So it says, based on this model, find the volume of the tank. So if we're finding a volume of the tank, again, we're finding like an area, right? So we have something that is in square feet, and we need to multiply by feet in order to get this volume. Okay, so we want to integrate our f of h, which, as I told you, was in square feet. So if I integrate it, it's going to be in cubic feet. All right, so I'm going to integrate from, let's see, modeled by the function f, blah, 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 blah. And it ends up having a height of 10 feet. So it says the tank has a height of 10 feet. So I want my h, my height, to go from 0 all the way to the full height, which is 10 feet. So I'm going to do 0 to 10. All right, and that's going to be in terms of h. So I'm going to write dh there. And we can put this into our calculator. So what I recommend is if you're using a calculator, put this in for y1. So that way it's easier to integrate, and if you need to find like an intersection point or something, you'll have it in there. So we're going to go to y equals, and we're going to put in this function, which was 50.3 divided by, and I'm going to put a parenthesis, so e to the 0.2h or 2.2x on the calculator, and plus x. All right, and then I get out of there, And since I have that in for y1, I don't want to type it in again if I'm trying to do Math 9. So your Math 9 might make this a little bit fancier. It might actually set up the integral. This is an older calculator. So I'm going to do vars, y vars, function y1. And I'm going to integrate from x equals 0 to x equals 10. And in our problem, it's not x, it's h, but you get what I'm saying. So when I integrate, it gives me a value. So it ends up giving me 101.325 if we do 3 decimals. And again, that would be in cubic feet. Okay, so this last part, part D, is a little tricky. So it says water is pumped into the tank. When the height of the water is 5 feet, the height is increasing at the rate of 0.26 foot per minute. Using the model from part C, find the rate at which the volume of the water is changing with respect to time when the height of the water is 5 feet. Indicate units of measure. So there's a lot of clues here that we're going to do kind of a related rates type thing. So see how we're talking about like feet per minute, and we're saying when the height of the water is 5 feet. Okay, so we know that we have some kind of related rates problem. But this one is probably one of the trickiest related rates problems that I've seen on one of the AP exams. And I don't feel like a lot of people probably got this part right last year, so don't feel bad if you're not getting every single thing right. So here we go. So if I have my volume, and I want to talk about V of h, okay, so the volume when the height is h feet. I would integrate from 0 to whatever that height is. And I would integrate this f of h function. Okay, but I don't want to write f of h dh because I don't want to use the same variable as what I had right here, right? So I'm going to call it f of x dx. Okay, so here's kind of the weird part. Okay, and you don't have to write this, just kind of look for a second. If I want to find v prime, my v prime would be with respect to h, okay? So if I was taking the derivative of v, I know that if I take the derivative of an integral, right, I basically take whatever's here and I can replace it. Okay, so I would put that in, and I would have f of h. Okay? This really isn't too complicated, but it's not really what I want. The question is, what is the rate of change of the volume with respect to time? Okay, and this isn't with respect to time, it's with respect to the height. Okay, so we actually don't want v prime of h. So if you think back way back when we first started talking about the chain rule, okay, we would have things where we would have everything where we write it in terms of u, okay? So if I was trying to find like f prime of a g of x function, okay, we know that we would have to do the we'd have to do the derivative of the inside, right? So what we went through is we went through things like this. If I want dv over dt, I can take the derivative of v with respect to h, but then I have to multiply by its chain, dh over dt. Okay, so this should make complete sense when we think about the fundamental theorem. We know that if we had things like 0 to x squared, with our fundamental theorem, we'd tack on a times 2x at the end. Okay, that's what we're going to do here. So I'm going to take the derivative, which is going to be f of h, but then I'm going to tack on the derivative of h, which is going to be dh over dt, because it's with respect to time. Okay, so it's a little bit tricky. So now we're going to find each of those things. So if I want to find f of h I can get from this function right here. Okay, so luckily I already had that in my graphing calculator, so I'm going to go back to my graphing calculator. Oh, of course, mine's all messed up here. So I'm going to go back into my graphing calculator. I don't want to have to put it back in. And I would go back into my y equals, which you guys already have it set up as. And I would plug in either in the table, or I could do on the graph, I could put in the value. And I'm going to put in the number 5, because we're saying when the height is 5. Okay, so this ends up being f of 5. Okay, and then dh over dt, well, that was given to us. It says that the height is increasing at a rate of 0.26 feet per minute. Okay, so that's what we're putting in here. Okay, so when you find f of 5 in your calculator, which I found earlier, and then multiply by 0.26, you end up getting like 1.694 something. Okay, and then if you think about our units, we end up getting cubic feet per whatever our time units were, which was minutes, because we're finding dV over dt, right? So we have cubic feet per minute, and that's our answer. And if you think about our units even right here and right here, it will make sense that we have cubic feet per minute because our f of h was the area in square feet. So this would be like square feet, and this one would be feet per minute. So when we multiply those, we do indeed get the feet cubed per minute. Okay, so then I think it asks for like a write this out in words type thing. So it says, indicate units of measure. Okay, so I guess it says find the rate at which the volume of the water is changing with respect to time. So if you want to write a little sentence, you could say, when our height is equal to 5, and that would be in feet if you want to write feet, the volume is changing at a rate of 1.694 cubic feet per minute. Okay. So yet again, don't feel bad if you had trouble with that one. Sometimes they have questions for the first time on an AP test. This was kind of a first time for this type of question, where we had to do this fundamental theorem, but it involved the chain rule in kind of a weird way with these units of measure. So don't feel bad if you're not getting every single point right, because what probably happened last year is a lot of people probably missed this. And so you're just trying to get kind of better than the average, which I think many of you guys are definitely ready to do. Okay, so let's talk about scoring. So you get 1 point for having the units correct in part A, C, and D. So you have to look at all three parts, A, C, and D, and you have to have your units on all of them. So we had cubic feet, we had cubic feet here, and then D, we had cubic feet per minute. So you would have to have all three of those in order to get that one check. All right, for part A, we get 1 point for the left Riemann sum. So remember, you have to write like products and sums here, and 1 point for the approximation. Part B, we got 1 point for knowing it was an overestimate and having some kind of reason for that. So we had because A is decreasing. Part C, we had 1 point for setting up the integral, which is our 0 to 10 f of h dh, and 1 point for our answer, which is the 101 number. D, we got 2 points for getting this correct derivative. So they probably gave you a point along the way if you had, maybe if you had like f of h in there, but you forgot the chain, the dh over dt. And then you got 1 point for your final answer, which was 1.694. All right, so let's go on to question number 2. Question number 2. So we actually did this in class the other day. So it says when a certain grocery store opens, it has 50 pounds of bananas on a display table. Customers remove bananas from the display table at a rate modeled by f of t equals 10 plus blah, blah, blah. Where f of t is measured in pounds per hour, t is the number of hours left the store opened. After the store has been open for 3 hours, store employees add bananas to the display table given by g of t, where g of t is in pounds per hour and t is the number of hours left the store open. So part A, it says how many pounds of bananas are removed from the display table during the first 2 hours the store is open. So if we're talking about the number of bananas that are removed, number of pounds of bananas that are removed, we need to talk about this f of t function. So customers are removing them at that rate. Okay, this was in pounds per hour, so in order to get pounds, I have to integrate, right? This is a rate originally, so I need to go backwards into the antiderivative. So for part A, you should have the integral from 0 to 2, because it said the first 2 hours, of f of t dt. Okay, so since this is a calculator question, I would make sure that you have everything in your calculator. So I would put your y1 as your f of t function. So we're going to go through, we're going to do 10 plus 0.8 t multiplied by sine of t cubed, and then divided by 100. And then we're also going to put the g of t in while we're at it, because we're probably going to have to find intersection points, right, or antiderivatives or whatever. So I'm going to put in natural log of t squared plus 2t, and like that. Okay, so I'm worried about this first function, y1. And so I'm going to integrate that y1. So on my main screen, I can do math 9. Yours might show the integral there, our y-vars function. We're going to integrate y1 going from x values of 0 to 2. So I put x comma 0 comma 2. Okay, when I hit enter, I get 20.051. So if you don't have that, just make sure your mode is set to radians because it has that sine function in there. Okay, so this would be the number of pounds of bananas. So let's say something like 20.051 pounds of bananas are removed over the first 2 hours. Okay, so B says find f prime of 7. Okay, so if you want to find f prime of 7, and you look at f, and you're like, ooh, I don't want to take the derivative of that, right? We know how to take the derivative of this, but it's going to involve the product rule with the chain rule, right? All we have to do is we have to go into our calculator, and we can do math 8. So if we do math 8, that's our n-deriv. And again, we can do vars, y vars, function, y1, and this x value that we're going to evaluate it at is at 7. Okay, so it says negative 8.1195. So I'm going to say negative 8.120. Okay, so I need to indicate that I've done that on my calculator in some way. So I'm going to write f prime of 7 equals, and they'll know that you found that value on the calculator. So we're going to get that. All right, you could also truncate and have negative 8.119. Okay, so we need to use correct units to explain this. And this is what I was saying the graders kind of debated about last year. Okay, so on the answer key it says, after the store has been open 7 hours, the rate at which the bananas are being removed is decreasing by this. So we need to say at, because it does say, you know, at exactly 7. So I'm going to say at time t equals 7 hours. Instead of using the word after. So at t equals 7 hours, the rate at which the bananas are being removed is decreasing by, and this is where it gets tricky. So if you think about what F was in, it was in pounds per hour. So pounds of bananas per hour. And now we're taking a rate of that. So if I take a derivative of F, that's going to be pounds per hour per hour. So we're going to say something like that. So I'm going to say is decreasing by 8.120 pounds per hour. And you could say every hour, or you could say another per hour. Okay, so that's a tricky one. So C, is the number of pounds of bananas on the display table increasing or decreasing at time 5? So at time 5, our bananas are being removed, but we're also having the store add bananas at that point. Okay, so we need to know if our f of t is being outweighed by this g of t. Okay, so we want to know what happens when we subtract these two. Okay, so at time 5, let's go ahead and find if the amount that we're gaining is more than the amount that we're losing. So let's just find g of 5 and f of 5. Okay, and then we'll compare them. Maybe that's an easy way of you guys to think of it. So if I go back into my graphing calculator and I go maybe to table, so I'll get both those values right away. And I put in 5. Okay, remember you can put in whatever values you want by going to table set and making sure it's under ask. But yours is probably set that way already. So you can just put in 5. And we get 13.796 and we get 11.533. And then 11.533. Okay, so we want to compare those two. We want to say which one's bigger. Okay. So it looks like f of 5 is greater than g of 5. which means the amount that the people are taking, right, the customers are taking the bananas faster than they're putting the bananas up. So what does this mean? That it means it's decreasing. So since f of 5 is greater than g of 5, the number of pounds of bananas is decreasing. Okay, and then the last part, part D, so it says how many pounds of bananas are on the display table at time 8. Okay, so this is where it's a little tricky. We need to know how many we started with. So if you go back up here, we have 50 pounds of bananas on the display table. So that's our initial condition. So we're going to say, well, we started with 50. And then after the first 8 hours, we lose f of t dt. So instead of having a plus there, I need to make this a minus. And then I gain from time 3 to 8, right? Because I started after 3 hours. I gain my g of t dt. Okay, and I can integrate all that on my calculator, do my math 9 thing. I end up getting like 23.347, somewhere around there. Okay, and what this is pounds of bananas. Okay, and you could say at time 8 or whatever, but I think it's fine if you just say that many pounds of bananas, and it's, you would assume it's at time 8 because that's what they asked. Okay, so let's look at the scoring. So for part A, we got 1 point for the integral setup. So the 0 to 2 f of t dt, 1 point for our answer. For part B, we got 1 point for the value, meaning that negative 8.120, and 1 point for the meaning. Okay, and that's what I said. The graders actually said that this was not right. It needed to say at time t equals 7 hours. Not after that, because there was a little bit of a argument about it, I guess. They were disagreeing about saying, well, what if it was at 7.5, right? So they're very, very picky, as I've told you before. All right, and then C, so if you consider f of 5 and also g of 5, and then you give your answer with reason, you get 2 points. And then part D, you've got 2 points for the integrals, so having this part and also this part, and then 1 point for your answer, which was the 23.347. All right, so let's go ahead and look at number 3. So number 3 says the function f is differentiable in the closed interval of negative 6 to 5 and satisfies f of negative 2 is equal to 7. The graph of f prime, the derivative of f, consists of a semicircle and 3 line segments as shown in the figure above. So find the values of f of negative 6 and f of 5. So again, this is the graph of f prime. So if I want to get f of negative 6 and f of 5, I have to integrate in some way. Okay, and I'm also going to have to use this initial condition. So make sure you always pay attention to your initial conditions. Okay, so the easiest way for us to think about this is with our fundamental theorem of calculus part 1. So if I want an x value of negative 6 and I have an x value of negative 2, I'm going to say something like negative 6 to negative 2 of f prime. If I integrate that, oops, dx, I end up getting f of negative 2 minus f of negative 6. Okay? And that negative 6 to negative 2, well, what that is it's just this area that's right here. Okay? And that area ends up being a triangle, which has 1/2 base times height, which is 2. And then f of negative 2 was 7, and that allows us to find f of negative 6. Okay, so I end up getting 4 minus 7 equals negative f of negative 6. So I get negative 3 equals f of negative 6. So in other words, f of negative 6 is equal to 3. Okay. So we also have to find f of 5. Okay, so we could use what we just found, but what if we made a mistake on what we just found? So let's set it up again with this negative 2 that we had and 5. Okay, so I'm going to say the integral from negative 2 to 5 of f prime ends up being f of negative 2, whoops, f of 5, sorry, minus f of negative 2. Okay, so the way that I've talked about this before is it is an accumulation function, okay, and we talked about like snow before. So you might see like an AP answer key looks something like this. Okay, so knowing what that means is kind of key, right? You're saying, oh, if I start with negative 2 and I gain an amount from negative 2 to 5, that's going to give me my ending amount, which is f of 5. Okay, so that's what we're doing there. That's why we have this fundamental theorem of calculus. Make that look like f prime. It's looking a little messy. All right, so I find each of those things. so I find my area from -2 to 5, and I see that part of it dips below the axis, and then part of it's above again. Okay, so I still have my area, which was right here, which was 4, and then I'm taking away a semicircle area. So this is going to be 1/2 pi r squared is 2 squared. And then I'm gaining another triangle. So this is 1/2 base. So this base is 3, and the height is 2. Okay, and all of that's going to equal my f of 5, which we don't know, minus my f of -2, which is 7. Okay, so if I compute all of this and I simplify, I end up getting, and you can do all this if you want, 10 minus 2 pi equals f of 5. Okay, so I'm just going to simplify all that, and I get 10 minus 2 pi. Okay, so that's part A. So part B. So it says, on what intervals is f increasing? So immediately when you see f is increasing, you say, oh, that means that f prime is greater than 0. So we want to know where f prime is greater than 0. Well, this graph up here is the f prime function, and it's above the axis here, and it's above the axis here. So we're going to say that. So we're going to say f prime is greater than 0 on -6 to 2, and then on 3 to, not 3, sorry, 2 to 3, 4, 5. Okay. And you could have that -6 with brackets, it doesn't matter. All right. C. Find the absolute minimum value of f on the closed interval. So in order for something to have an absolute minimum, we need to show that something goes decreasing and increasing in order to be a minimum, or we could have endpoints. So you could have something like this, where this is the lowest point, right? So we can do this in a couple different ways. Okay, so first of all, let's think about, sometimes it's nice to have the number line to kind of plan. So let's say we have this number line f prime, and we're closed between -6 and 5. Okay, well, f prime is above the axis, and then it's below the axis starting at -2 to 2, and then it's above the axis again. So that means that f is increasing, then decreasing, and then increasing. So we have two possibilities for minimums. So we could have a minimum at -6, and we could have our absolute minimum at 2. Okay, and those are really the only two possibilities. Okay, but if we didn't have that number line, we could do what we call the candidates test. So we could have x values and f of x values. Okay, and we already know some of these because we found, well, these are our candidates, -6, -2, 2, and 5, the only critical values in the endpoints, right? And we found some of these. We found that f of -6 was 3, and we found f of 5 was 10 minus 2 pi. Okay? So the only other ones we need to find are this f of -2 and 2. Well, we have f of -2 is 7. So really the only thing we need to find is f of 2. So how do we find f of 2? We find it exactly as we did in part A. So we can do something like -2 to 2, and we say f prime of x dx gives me f of 2 minus f of -2. Okay, and if you see -2 to 2, that's that negative value. It gives me a -1/2 pi r squared. Okay, so I end up getting -2 pi. So this is equal to f of 2 minus 7. So I'm going to add that 7 over to get f of 2. So I have 7 minus 2 pi. So now I start comparing, and I want to know which one is the smallest one of all. Okay, so 7 minus 2 pi is going to be, well, 2 pi is like 6.28, right? So 7 minus 6.28, that's like point something. It's less than 1. Okay, that is the smallest one. So this is the one that is the absolute min. Now, since I didn't technically use this, I really don't have to write about it. But remember, if we have a number line, it's very easy just to be like, oh, f prime is greater than 0 on -6 to -2, union 2 to 5. F prime is less than 0 on -2 to 2. So you could very quickly write that, especially at the end of the test, just in case you're not sure, like, ooh, did I really use the candidates test, or did I use this increasing, decreasing thing? Okay, in this case, we actually just used the candidates test. We had most of those values anyway. Okay, but really, if I was using kind of a combination of them, I didn't have to put all those values in. I really just had to try the two possibilities, -6 and 2, right? I didn't have to try all 4 of them. Okay, so continuing on, So it says justify your answer. So we're going to write absolute min of 7 minus 2 pi, and that's what it is when we talk about a value, absolute minimum value of f. It's a y value at x equals 2, and you could just write by the candidate's test, and they would know. Okay, if you don't write by the candidate's test, it's fine because you have all of your work shown. All right, so then the next part says, for each of f double prime of -5 and f double prime of 3, find the value or explain why it does not exist. Okay, so let's talk about f double prime of 5, and let's talk about -5, and f double prime of 3. Okay, so if we look at our graph of f prime, if I want to talk about f double prime, it's going to be the slope of f prime. Okay, so I want to know the slope at -5. Okay, so what is the slope of this line? Well, it looks like it goes down 2 over 1, 2, 3, 4. So if I go down 2 over 4, it's going to be -1/2. So that one's good. We have that one. But then if I talk about f double prime of 3, f double prime of 3 is right here. The slope at 3, the slope of f prime at 3, does not exist. Okay? So I'm going to say it's undefined because the slope of f prime at x equals 3 does not exist. And you could write in parentheses something like cusp, corner, right? So it's a corner in this case. Okay, so if you wanted to write this out in a fancy way, you could say something like the limit as x goes to 3 from the left of f prime of x is not equal to the limit, well, actually I should say f double prime of x. The limit as x goes to 3 from the right of f double prime of x. Okay, those are not the same values. If you look at it, one of them has a slope of up 1, 2 over 1, so slope of 2. The other one has a slope of -2. Okay, so that's what we're saying there. All right, so scoring. So for part A, we got 3 points. So 1 point for using the initial condition somewhere, so the f of -2 value. 1 point for finding f of -6, and 1 point for finding f of 5. For part B, we got 2 points, so having the answer, but also with justification. So we said f prime was greater than 0 on the intervals, therefore f is increasing on those intervals. C, we got 1 point for considering that x is equal to 2 as a possibility, and then 1 point for the answer with justification. And then part D, we got 1 point for finding f double prime of -5, 1 point for explaining why f double prime of 3 does not exist. Okay, so let's look at the next one. So question 4. Okay, so question number 4. At time 0, a boiled potato is taken from a pot on a stove and left to cool in a kitchen. The internal temperature of the potato is 91 degrees Celsius at time t equals 0, and the internal temperature of the potato is greater than 27 degrees Celsius for all times t is greater than 0. The internal temperature of the potato at time t minutes can be modeled by the function h that satisfies the differential equation given. So where h of t is measured in degrees Celsius and h of 0 is 91. So again, this is our initial condition. It was mentioned twice in this problem. So A says, write an equation for the line tangent to the graph of h at time t equals 0. Use this equation to approximate the internal temperature of the potato at time t equals 3. So we know in order to find the equation of a tangent line, we need 2 things. We need a point and we need a slope. So our point is given to us. So we said at time t equals 0, we have an h value of 91. That was our initial condition. But our slope is not given to us, okay? So our slope is h prime of 0. Well, luckily we have dh over dt, right? So we want to plug in time t equals 0 into that equation. So we go up here. Okay, but it's a little tricky. This h isn't a time, so don't plug in t equals 0 there. We're actually going to plug in the value for h at time t equals 0. So we want to plug in h prime of 0 there. Not h prime, sorry, h of 0. So our h of 0 is 91. So we're going to have -1/4, 91 minus 27. So when we find that, we end up getting, let's see, 64. so -1/4, and then 64, so -16. Okay, so that's going to be our slope. I should have written it down here. So we end up getting y minus y1 equals m times x minus x1. But be careful, our variables are not in terms of y and x, right? They're in terms of h and t. So we want to say h minus 91 equals m, which is -16, times t minus 0, right? So we end up getting -16t plus 91 if we add it over. So that's our equation of our tangent line for h with respect to time. So that's like our x value in this case. So b. Oh, hang on, I didn't finish that one. So it says, use this equation to approximate the internal temperature of the potato at time t equals 3. Okay, so it's not really super close. So usually when we have these approximation using tangent lines, we're really, really close to the x value or t value. So we had at time 0, and we're jumping all the way to time t equals 3. So think about what happens when you have a curve and you find a tangent line and you're really, really close. So if this was time 0, if I just go slightly off it to like 0.1, right, I'm really close to the actual, like my tangent line value is really close to the actual value on the curve. Okay, but if I'm jumping way over here, like those values could be really, really far apart. So I don't know, maybe these are really far apart. Let's see. So we're going to find h of 3, which is going to be approximately -16 times 3 plus 91. So -16 times 3 is -48 plus 91. So if I subtract those out, I end up getting 43. So I have 43 degrees Celsius is the approximation. Okay, so B. So B says, use the second derivative, d2h over dt squared, to determine whether your answer in part A is an underestimate or an overestimate. So we're going to talk about the concavity on this one. So I first want to find the second derivative, so d2h over dt squared. So I'm going to take the derivative of this right here. Okay, so I could multiply that -1/4 in first if I want, or I can take the derivative using the product rule. So I have the first times the derivative of the second, dh over dt, minus 0, right? And then plus the derivative of the first would be 0 times the second, which would be the h minus 27, but of course the second part's 0. So we get -1/4, and dh over dt, we said, let me think. So we're finding it at time t equals 3. So dh over dt, we just found an approximation. So we found it was -16, right? So we're going to have dh over dt at time 3. I don't know what I want to plug in here. Oh, hang on. I know what I want to do. Okay, so I want to plug in my dh over dt, which is just this in general, right? It's this -1/4 times h minus 27. Sorry, that took me a second. All right, so I'm going to get +1/16 times h minus 27. And I want to know if this is concave up or concave down at time, well, I guess for any time greater than 0. So is this concave up or concave down? So we said that, I think this is why they have this in here. So it says the internal temperature of the potato is greater than 27 for all times t is greater than 0. So we're going to say something like when t is greater than 0, h is greater than 27. So if h is greater than 27, then that means that the second derivative is greater than 0. So we're concave up, okay? Okay, so if h is concave up, so we could have something like that, right? Obviously, it would be a decreasing one, right? Because we're talking about the temperature, and the temperature would be getting colder as soon when it's taken out of the oven. So it's going to look something like that for H. Okay, so we want to know if our tangent line gives us an approximation that's above or below. Okay, so this would be the actual value along the curve, and this is the tangent line approximation. So we're going to be below. So I'm going to say something like, therefore, our approximation of 43 degrees Celsius is an underestimate. All right, so part C. So kind of putting this all together. So it says for T is less than 0, an alternate model for the internal temperature of the potato at time T minutes is the function G that satisfies this differential equation. Okay, so another differential equation. So where G of T is measured in degrees Celsius and G of 0 is equal to 91. So another initial condition. So find an expression for G of T. Based on this model, what is the internal temperature of the potato at time T equals 3? So they're not using our calculus keywords, which really bothers me, because I've always trained you guys to say, oh, when it says find the particular solution to this differential equation, you guys know what to do. Okay, it's a separable differential equation. You separate both of them. But it is using this word find, and it's talking about G of T. So if we're talking about G of T, and originally we had dg over dt, we have to solve this differential equation. So for part C, we're going to separate this differential equation. We're going to have dg over dt equals negative g minus 27 to the 2/3. All right, so it's kind of weird because there's no t's. So I'm going to leave the negative 1 over here, and I'm going to do dt. And then I'm going to bring this part to the other side by dividing it over. Okay, so I'm going to have 1 over g minus 27 to the 2/3 dg. All right, so this ends up being the integral of g minus 27 to the negative 2/3 dg equals negative 1 dt. And I could have brought in the negative 1 to the other side too. I didn't have to leave it on that side. So if I add 1 to the power, well, really, I mean, what am I doing here? I'm really doing in my head a u substitution, but du is not gaining like a new number out front or anything. I get a 1 dg. So I don't have like a 1/2 or a 2/3 or something like that out front. So I'm going to do this without actually writing the u substitution. And I'm going to add 1 to the power. And I'm going to do 1 over that new power. So I'm going to have a 3 out front. Equals negative t plus c. And then I plug in that initial condition of g of 0 is equal to 91. So I'm going to have 91 minus 27 to the 1/3 times 3 equals negative 0 plus c. So I get c equals 3 times, this is 64, it's the cube root of 64. Tricky ones without calculators, right? So I end up getting 3 times 4 is equal to c, so c is 12. So when I go back and I plug in, I get 3 times the cube root, right, that was the 1/3 thing, g minus 27 equals negative t plus 12. I'm going to divide by 3, and then I'm going to cube both sides. Oh, I left off my cube. I don't have enough room for my cube. That's where I get to move things over. It's so exciting. So I'm going to have cubed, and that's going to be g minus 27, so my g is equal to the lovely negative t plus 12 over 3 cubed plus 27. All right, so it says based on this model, what is the internal temperature of the potato at time t equals 3? So let's see. Okay, so if I plug in to my g function that I just found, well, capital G, of 3, I end up getting 12 minus 3 over 3 cubed plus 27. And so I get 9 over 3, which is 3 cubed, plus 27. So I get 54 degrees Celsius. And so that's what it was asking when it said, Find an expression for g of t based on this model. What is the internal temperature at time t equals 3? So previously we had an approximation that was was 43 degrees Celsius. And we just found that based on another model, it should be closer to like 54 degrees Celsius. Okay, so let's go ahead and do the next problem as well. Oh, scoring. So for part A, you got 1 point for the slope, 1 point for the tangent line, and 1 point for the approximation. For part B, you got 1 point for an underestimate with reason. And then part C was 5 points. So remember, when we have these separation of variable problems, you get 0 out of 5 if you did no separation of variables. So you got 1 point for separating, 1 point for finding both antiderivatives correctly. So the 3g minus 27 to the 1/3 and the negative t part. 1 point for realizing that we have an initial condition, and they also combine that with using 1 point for having the plus c and 1 point for using the initial condition. A lot of times they separate those into points. And then equation involving g and t, and then 1 point for finding g of t and also g of 3. So this was kind of a tricky one. It's not scored how our normal separation of variables is. There's a lot of ones where it's like 1 point for having this and this, which is not usual on that. And then again, if you have no plus c, you only get a max of 2 out of 5 points on that. Number 5, so two particles move along the x-axis. So for time 0 to 8, the position of the particle p is given by x subscript p, which is given, and while the velocity of the particle q is given by v of q equals t squared minus 8t plus 15. Particle q is at position 5 at time t equals 0. Okay, that's an initial condition. So between 0 and 8, when is particle p moving to the left? So in order for particle p to be moving to the left, we need the velocity to be less than 0. So we have the position. Okay, so if we want the velocity, we have to take the derivative. So we're going to do xp prime of t, which is going to be vp of t. So that's going to be the derivative of x subscript p. I know you guys love subscripts, right? So 1 over t squared minus 2t plus 10. And then we're going to multiply by the chain, which is 2t minus 2. So as we start trying to figure out where that's less than 0, we have two critical values. We can factor out the 2 on the top, and then along the bottom, if I have t squared minus 2t plus 10, that's actually positive everywhere. So if you think about what that looks like, it has a y intercept of 10, and you can try to find where it's equal to 0, but it actually isn't. So like if you started doing the quadratic formula, you'd have negative b, so 2 plus or minus the square root of b squared is 4 minus 4a and then c. So do you see how that discriminant, that part under the square root, is negative? So that means that it doesn't cross the axis. So we would have some kind of parabola where it's not crossing the x-axis. So that t squared minus 2t plus 10 is always greater than 0. So the only critical value that we have is 1. Oh, whoops, I wrote t minus 2. I bet you guys were screaming at me. Bonus point. All right, so I get t equals 1 as the critical value. So I'm trying to figure out where it's moving to the left, so I want to check on the left and the right of that. So if I plug in like 0 into this, remember the bottom is always positive, so I have a negative on top. And then if I plug in something like 2, I end up getting a positive on top. So we're decreasing and then we're increasing. Okay, so it's moving to the left when we have the v subscript p is less than 0, right? So it's anything that's less than 1. So let's write that. So we would say something like xp prime of t is greater than 0 on 1 to infinity. Xp prime of t is less than 0 on negative infinity to 1. Actually, we're between 0 and 8, so I'm going to adjust these a little bit. I'm going to say 1 to 8, and then I'm going to say 0 to 1. Therefore, P moves to the left on 0 to 1. All right, so B, so between 0 and 8, find all times t during which the two particles travel in the same direction. So the two particles travel in the same direction. So they're either moving to the right or moving to the left. So we need to figure out when our velocity, which we actually have the velocity for this, of q is less than 0 and greater than 0. So we're going to say t squared minus 8t plus 15 is equal to 0. And we factor, which is vq of t. I don't know if you have to write vq of t, but we could write that somewhere. So when you factor, we have t minus 5 and t minus 3. I would want both of them to be negative in order to multiply to be a positive and see how the outer and inner do combine to be negative 8. So I get t equals 5, and I have t equals 3. Okay, so if I line it up with my v subscript p, so I'm kind of below it, 0 to 8, and then previously I had 1, okay? But I'm going to do 3 and 5 are my critical values. Oops, that's an 8. All right, so as I start plugging things in, I end up getting that it's positive, negative, and positive. And I can kind of tell that already because this is a parabola that's above the axis, below the axis, above the axis. So we want to know where it's both positive or both negative. So we were going up, down, and then up. So let's look at between 0 and 1. Well, 0 and 1 were positive for q, but we're negative for p. So that doesn't work. So let's look at the next interval, like 1 to 3. All right, so 1 to 8 was positive. Well, 1 to 3 is also positive. So we're going to say 1 to 3. And then we're going to look for some other things. So we're going to say, well, from 3 to 5. Well, 3 to 5 was negative, and it was positive for v subscript p, so it doesn't work. And then 5 to 8, yep, that works. So we're going to say that. So on the intervals 1 to 3 and 5 to 8, v of p and v subscript q travel in the same direction. Because they have the same sign. All right, so C, so find the acceleration of particle q at time 2. So we want to find the derivative of v subscript q, which is going to be our acceleration for q. So our derivative is going to be 2t minus 8. And we want to plug in 2. Don't you love these subscripts? So we have 2 times 2 minus 8, which ends up being negative 4. All right, so it says, is the speed increasing, decreasing, or neither at time t equals 2? Explain your reasoning. So in order for the speed to be increasing, I don't know if you guys remember this, it's been a while since we've talked about it, we need the acceleration and our velocity to have the same sign. So right now we have that this is less than 0. So we want to get our velocity at time 2 as well. So if I plug in 2 into my velocity function, which was up here, I end up getting 2 squared minus 8 times 2 plus 15. So I get 4 minus 16 plus 15. Which ends up being negative 1 plus 4, 3, which is greater than 0. So since they do not have the same sign, this means that the speed would be decreasing. So the speed is decreasing at t equals 2 because v of 2 and a of 2, and we'll write our little subscripts there, do not have the same signs. So they have opposite signs. Okay, so then part D, so find the position of the particle q the first time it changes directions. So first of all, we need to know where it changes directions. So that means we want to find where v of q is equal to 0. So v of q was the t squared minus 8t plus 15. And we found that it equals 0 at 3 and at 5. Okay. So when it first changes direction is at time 3. So we want to integrate, right, because we're trying to find the position. So we want to integrate our velocity function. And then we need to consider that we weren't at a position of 0 when we started. We were at a position of 5. So what we're going to do is we're going to say, well, we started at 5, and I'm going to integrate from 0 to 3 of this VQT, and that's going to get my position, my XQ, at time 5. Okay, so I know that that looks really confusing when you see it, but basically it's the fundamental theorem. Okay, so when we say something like 0 to 3 f prime of t, and we integrate, we end up getting f of 3 minus f of 0. Okay, and that's what we're doing. It's like we're taking that time 0 and we're adding how much it changed over that interval 0 to 3 to get its final position at 3. Okay, so we're just doing a fundamental theorem problem, although it looks very confusing with the subscripts and so on, I'm sure. So if I integrate this VQ, so t squared minus 8t plus 15, and I go from 0 to 3, I'm going to get 1/3 t cubed minus 4t squared plus 15t, going from 0 to 3, which is pretty tricky to do without a calculator, but we can manage. We're going to get that position at time 5. So I'm going to have 5 plus 1/3 times 27 minus 4 times 9 plus 15 times 3. And then all of the rest of it ends up being 0, which is kind of nice. Wouldn't that be terrible if they had it from 1 to 3 or something? Oh, man. All right, so I'm going to have 9 minus 36 plus 45. And I'm going to do plus 5. So I end up getting 23. So you can check that, but make sure it's 23. So we get x subscript q of 5 is 23. All right, so let's look at our scoring for this one. So for part A, we got 2 points. So 1 point for getting our derivative. So the 2 times the quantity of t minus 1 all over t squared minus 2t plus 10. So you didn't have to factor that out or anything. 1 point for having the interval, which is from 0 to 1. For part B, we got 2 points for the intervals, and then we got 1 point out of 2 if only one interval with analysis. So if we had left off like, so you know how it was like 1 to 3 and 5 to 8 if we had left off one of them. And we got 0 out of 2 if we had no reasoning for this. For part C, you got 1 point for getting a subscript q of 2 correct, and 1 point for saying that the speed was decreasing. And for part 3, you got 1 point for having the correct antiderivative, which is the 1/3 t cubed minus 4t squared plus 15. 1 point for using the initial condition of the plus 5, and 1 point for your answer, which is 23. All right, last one. So number 6, it says let f be the function defined by f of x is equal to cosine of 2x plus e to the sine of x. And let g be a differentiable function. The table above gives values of g and its derivative g prime as selected values. And then h is the function graphed. So they're really just, 2017 was when the test was changed, and they are really just going for it. So they're giving you not only the table, but their graph and also a function on this one. How fun. So letter A says find the slope of the line tangent to the graph of f at x equals pi. All right, so if we're doing this, all we're going to do is we're going to find the slope. So we want to find f prime of x for this function. So f prime of x is going to be derivative of cosine is negative sine. So I'm going to have negative sine of 2x times the chain of 2. Plus, I'm going to have e to the sine of x times its chain, which is times cosine of x. And I'm going to plug in x equals pi. Sorry, I don't know why I had to. So pi. So I have negative sine of 2 pi, which is kind of nice because that becomes 0. And then I'm going to have e to the sine of pi times cosine of pi. As I said, all of this goes to 0. This power is 0, so e to the 0 is 1. And then cosine of pi is -1. So your answer should be -1 for that. All right, B. Let k be the function defined by k of x is equal to h of f of x. Find k prime of phi. So for part B, if I'm finding k prime of x, this is the chain rule. I'm going to do h prime of the inside multiplied by the derivative of the inside. So I'm going to have k prime of pi is going to be h prime of f of pi times f prime of pi. So I'm going to get h prime of f of pi. So I go and I look at my f function, which was up at the top, and I need to find that. So side note, f of pi is going to be cosine of 2 pi plus e to the sine of pi. So cosine of 2 pi is going to be 1, and then e to the 0 is 1, so all of that is 2. So I'm going to have f prime, or sorry, f of pi is 2, and then now I'm doing f prime of pi, which I just found in part A, which is -1. So if you didn't get the answer for part A, just write 5 and then put 5 there so you at least get the point for the setup. So now we have h prime of 2. So we have to go and look at 2, and we need its slope there. So the slope of that line, it looks like it goes down 1 over 1, 2, 3. So it looks like it's -1/3 times that -1. So I believe your answer should be 1/3. All right, C. So it says let m be the function defined by m of x is equal to g of -2x times h of x. Find m prime of 2. Okay, so if I find m prime of x, it's going to be g prime. Well, we're doing the product rule, so I don't care which one you do the derivative of first. So let's do g prime of -2x times its chain, -2. So that was the derivative of that. Now we multiply by h of x how it is, so times h of x. And then I do plus. Now I keep the g of -2x the way it is, and I multiply by the derivative of h of x, so I have h prime of x. So m prime of 2 is going to be g prime of -4 times -2 times h of 2. So h of 2, if I look at my graph, it's right there. Ooh, it's kind of hard to find. We're going to leave that as it is for now. And then plus g prime of, or g of -4. So g of -4 is in our table. It's 5 times h prime of 2. All right, and h prime of 2 we actually already found. It was the slope of this line, which is down 1 over 3. So we at least have that. So then we're like, well, what are these things? So g prime of -4 is -1. So then we have times -2, and then we have this thing, and we're like, ooh, what is this? H of 2. Okay, but this is really not that bad if you think about algebra 1. Okay, so sometimes this algebra 1 thing helps us. We can come up with the equation of this line. This line is really just y equals, we said down 1 over 3x, and the y-intercept is 0. So if I want to find this y value, when I go over 2, I just plug in an x value of 2, and I say, oh yeah, it went down 1 over 3, so down 1/3 every square, so it's going to be -2/3. So the y value there is -2/3. So I end up getting -4/3 minus 5/3, so -9/3, which is -3. So part D. So it says, is there a number c in the closed interval -5 to -3 such that g prime of c is equal to -4? Justify your answer. Okay, so let's think about the things that we have. So we do have g of x, and we also have g prime of x. So usually when we're talking about intervals, we're using one of two theorems. Okay, the first theorem is something we learned in the very beginning of the year. It's the intermediate value theorem. So the intermediate value theorem would say, let's say I was using g prime. I would want things to be on both sides of this -4. So if I look at g prime of -5, I have -3. And if I look at g prime of -3, I have 4. Those aren't like straddling, getting on both sides of that -4, so I can't use this intermediate value theorem. So then let's think about the mean value theorem. So the mean value theorem is the one that says, oh, if you have a continuous and differentiable function and you find the slope between two endpoints, you have to have a place somewhere between those two endpoints where you have that same slope for some value of c, okay? So let's find g of -3 minus g of -5, right? The f of b minus f of a all over b minus a, only now we're using g's, so be careful. So we're going to have g of -3 minus g of -5 all over -3 minus a -5. So I look those up in my chart. So I have 4 minus g of -5 is -3 all over, oops, I looked up the wrong one, didn't I? Not -3. 10. I got to circle these because I'm going to get a little lost here. So I don't have 4, I have 2, don't I? I got to be careful. Jeez. All right, so I have 2 minus 10 all over -3 plus 5. So I get -8 all over 2, which is -4. Okay, and that's what I want. I want it to be equal to whatever number I had right here. Okay, if it's equal, then that's good for us. That means that, yes, there is something. So we need to say, since g is continuous and differentiable on the interval, -5 to -3, there is a c such that g prime of c is equal to -4. And you can write by the MVT if you really want to, by the MVT if you want to really impress them. All right, so scoring for this one. For part A, we had f prime of pi, we got a point, so we got -1. For part B, we got a point for having k prime of x, which involved the chain rule, and we got a point for finding k prime of pi was equal to 1/3. Part C, we got 2 points for finding the correct derivative m prime of x, so it's pretty complicated. It involves, as you know, like the product rule with the chain rule. And then 1 point for m prime of 2. And then part D, we got 1 point for finding that average rate of change of g on the interval and 1 point for the justification using the mean value theorem. All right, so that's the end of the 2017 exam. Don't worry if you felt like that was a very tricky exam. From many of the message boards after that test, there were a lot of calc teachers that were like, oh my gosh, I don't know how my students did on this. And like I told you before, if you feel like something's really hard, like if the test is really hard, you don't have to get every single question right. It's a bell curve. You just have to do better than the general population, which I think many of you can do. So if you have any questions, let me know. Good luck, rest up, and good luck on Tuesday.